In this video, we will look at the final project from my book, Sound and Music Projects for Eurorack and Beyond. And so that final project is a Eurorack frequency modulation synthesizer that can be built fairly inexpensively using the concepts from the book. The project is based on what I call a backpack. It's a custom printed circuit board that contains circuitry for control voltage input and gate input. And currently in this iteration, I just have the first control voltage and gate assigned to control the unit. And then of course you could customize that second input for anything that you'd want, such as a second voice, or perhaps assignable control of one of the parameters of the synthesizer. In terms of the code base, the synthesizer has 4 operators that come from that powerful Teensy library, and those operators can be configured in several different algorithms that essentially determine the signal flow of those operators. There is a page to control the frequency, both fine and coarse tuning, and the amplitude of each of those. And depending on how those operators are functioning, that amplitude will be heard as modulation or just as an increase in the volume or the amplitude of that signal. Let's take a look at the interface of the Eurosynthesizer. This is based on a simple OLED display and 4 rotary encoders / push buttons. And I describe a primitive version of this interface early in the book, I think in the 3rd chapter. And so the idea here is we have different pages that are associated with the different buttons from the encoders. So for example, we can click to get fine and coarse tuning. With that switch, we've got output level and feedback level. Here we have the algorithm page, which toggles through the 10 different algorithms. And then finally, a utility page. And so this, if you want to take a look at the voltage inputs and gate status, and I find this useful as I was designing my own control voltage converter to double check with this page, and so that might be useful. Let's go back to the main page and talk through one approach to sound design. So to start with, let's visit the algorithm page, and we'll keep it in this first algorithm. And for tuning, let's keep these all on the first octave. Coarse tuning, everything is off. And now for output level, I have everything turned off except for the first operator. A fairly uninspiring sine wave. So now let's increase the level of the operator that would modulate that, the one just prior in that flow, if you will. And so one thing I want to double check, let's turn up the fine tuning a little bit, and then we'll go back to the output level, and then we should be able to hear some modulation as I increase the output. So as I increase that modulation, there's a point where it transitions from simple modulation into frequency modulation, where we really start to hear those side bands. And so I just wanted to demonstrate that that's sort of the fundamental approach to doing FM synthesis, is this idea of using one operator to modulate another. And you can hear just with those 2 operators some complex timbres coming out of that already. Let's change from fine tuning to coarse and see what happens. Now you are starting to hear bell-like tones, and again, just from those 2 operators. All right, let's go back in and adjust the output level of the other two operators. So you can hear some drastic and startling effects just using that single first algorithm. So let's play with that a little bit just by changing the algorithm. So second. And so on. So let's try a sequence and to hear what that might sound like. Now let's try running that output through our custom digital signal processor. So to me, it's just thrilling to see a design come to life like that. And it's one of the compelling aspects of electronics and computer science that keeps me coming back. This idea that we can envision and then create a custom project that can enhance my own music making and provides opportunity to go really in innumerable directions in terms of envisioning a unique device and bringing that to fruition. And I want to, by way of encouragement, say that I am self-taught in terms of electronics and computer science. And I say that just to encourage readers who perhaps don't have a background in electrical engineering or computer science, that these technologies are scalable and you can start small with some of the simple projects in the book and using the breadboard. And as your skills grow and your knowledge base grows, you can do projects that really approach or even may equal professional quality instruments. So I hope that you found this video to be fun and useful, and thank you.